Hello, everyone. My name is Carl Freund, Cambrian-AI research and analyst firm that focuses on AI, especially on AI hardware. Real pleasure to chat with you today virtually, and I hope you have a very productive and useful day ahead of you. I've been asked by the Casako research team to talk about things that I'm interested in researching, things that I think are sort of the next leading edge of innovation that we are beginning to see. And normally, when I speak with the AI Hardware Summit crowd, I kind of do a who's who in the zoo. I walk through the 10 things I found last year that were truly remarkable. And since most of the members of the zoo are in the audience today, that's probably not a good use of my time or of yours. So instead, I'm going to talk about large language models. I firmly believe that large language models are really the next phase of AI. People say, what inning are we in AI? And I've always said, we're kind of at the bottom of the first, but I think with large language models, we're graduating all the way to the top of the second inning. I don't like baseball analogies. So I think there are three trends shaping the future of AI. Large language models themselves, the system designs required to run large language models, and the optimization techniques and methods for running large language models more cost effectively. Now, all three of these are research topics today. However, some of you in the audience and some of the vendors not in the audience are spending a lot of time and effort and money developing and benchmarking very large language models. And we call these large language models, they're not really large language models, but they started as large language models. They're now generative AI models that can generate lots of different things, including graphics and voice, and as well as language text. So these three trends, I believe, kind of cue up three questions we need to address. Are these things any use, any good? Do they have a use or purpose in life? Are they worth the money that people are spending to develop them? Or is it just a drag race? So how, when, and where might large models deliver real economic value? Second question, can training of these large language models become more affordable? Right now, this is a very exclusive domain of just the largest companies in the world. And there's a lot of other folks out there that would like to customize large models for their specific business purpose. And thirdly, and this is getting a lot of press, what are the social and ethical implications of large models? How can or should we contain bad actors, bad actions? Many governments around the world, including the United States government, France and the UK, are all formulating or implementing regulations to try to contain the potential outcome of these large models. Others would argue that the genie's already left the bottle. So it's an interesting food for thought for the beer hour, if we have one. Here's a few media highlights that really spurred my desire to share this with you. First, of course, with GPT-3. I mean, GPT-3 is doing all kinds of stuff that no one ever imagined it could do when OpenAI designed it. An interesting example is someone who unfortunately lost his fiancée. She died, and he missed her terribly, and decided to use GPT-3 to bring her, in effect, back to life. Echoes of the 2013 movie Her, if you all remember that. It was very, very convincing. OpenAI did shut that project down for violation of its usage models. But GPT-3 just started the ball rolling. Now we're seeing some amazing enhancements. We'll talk more about these. First of all, is Microsoft and NVIDIA have recently announced they have trained a 530 billion parameter model, and they've done so on both Microsoft Azure and on the NVIDIA Selene supercomputer. That's huge, and we'll talk more about what comes along with that, what comes around that. Most recently, Alibaba announced a new 10 trillion parameter model. It's not yet available. Not much is known about it, but they claim that they are able to train the M6 AI at only 1% of GPT-3's energy cost, which is pretty remarkable. That was an article on Medium by Alberto Romero. More recently, Google trained a trillion parameter model. Wow, we've gone from 85 billion to a trillion and even 10 trillion parameters in 6 months. The pace of innovation here is mind-boggling. So there are some serious companies with serious dollars and serious engineers, serious technology chasing this with a vengeance. But is it useful? Can it do anything worthwhile? Can it help businesses? Can it help academicians? Can it help science? Baidu certainly believes so. They have announced an 11 billion parameter, modest in comparison to an M6 or a Megatron, but still 11 billion parameters is pretty darn big. And they use it to build a chat box, the Plato XL chatbot. So there's first significant example, I think, of using large AI models in business. So let's talk about a couple of these. The Microsoft Azure and NVIDIA launch ecosystem. There will be some more news today from ML Commons, ML Perf organization, and NVIDIA and Microsoft describing benchmarks for their AI models. But the giant models that they've been able to run actually produce the fastest AI cloud in the industry. It's called NeMo Megatron. NeMo Megatron takes the Megatron 530 billion parameter model, adds customer data, and produces through distributed training and automated data curation a custom Megatron $530 billion model. It can be pretty useful. How do you run it? Well, you can't run a model that large on a single GPU. So you have to use distributed inference processing, and NVIDIA and Microsoft have worked together to establish the Triton Inference Server to be able to scale out inference processing at significant scale. What about affordability? Well, this is where M6 comes in. 10 trillion parameters, 1% of GPT-3's energy cost. So that means this is incredibly efficient AI processing at massive scale. So it started back in June when DAMO Academy, a research branch of Alibaba, announced they had built a large multimodal, multitasking language model with 1 trillion parameters. That's 5x GPT-3 size. That multimodal multitasking is critical because if all one of these models can do after just spending $10 million to train it is just write poetry, it's not going to be very useful. This is multimodal. It can deal with all kinds of data, from video for imagery and so forth, and numeric data. In just 6 months, they have improved M6 by 10x, and they now have a 10 trillion parameter model, 50 times the size of GPT-3 that was just announced last June. And they reduce energy consumption. Now, if you net that out, Alibaba only used 512 GPUs to train M6 in just 10 days. That would be compared to the 35,000 GPU days of A100 GPUs that effectively OpenAI used to build GPT-3. Again, the pace of innovation here is just mind-boggling, perhaps scary. So model generalization is important. Part of the affordability of large model development training is the usability of those models in multiple nodes, in multiple data types, in multiple use cases. And so M6 can do drawing, writing, do question and answers, and can be used in e-commerce, manufacturing, literature, and art, according to Alibaba. I can't wait to see this thing in action. It should be interesting. But massive models require rethinking of AI systems. You can only go so far with the current approach of putting accelerators, whether it's a GPU or Habana Labs accelerator, into a server and rack them and stack them. and run it out the road, and run it up the entire data center. You can do all that physically, but you can't scale your software. You can't scale the model today effectively using that infrastructure. So the infrastructure will change. NVIDIA is the first example of that. Earlier this year, they announced Grace, an ARM CPU they're building. It has nothing to do with ARM. It has everything to do with large AI, trillion parameter models. Cerebras has announced not only the wafer scale engine 2, but they've announced Memory X and Swarm X, all with the intent of supporting 100 trillion parameters. That's roughly the size of a human brain, if I get my math right. And they expect to be able to deliver that in 2022. Or I should say, I expect they will be able to deliver that in 2022. Graphcore's data center architecture doesn't scale as high, not yet, but it's got a modular architecture that I've been very interested in following, where you can take these intelligent processor units, plug and play with as many or as few CPU nodes as you like in the rack or across the rack. And so that's another example of a different approach to system architecture. Now, Google is benchmarking a massive AI model on TPU v4 now. Honestly, TPU v4 is only available to a select few. It has not been generally released on the GPU cloud. I expect that will change in the next 30 days. So since Christmas is coming, that means in the next 2 weeks. So I suspect that will have some significant enhancements in the interconnect strategy to build very large models. And Google earlier this year did project that TPU v4 would be available in the Google Compute Cloud by the end of 2021. Finally, a couple other startups, Salmonova and Grok should be mentioned. They're also providing systems, not chips. And again, tackling large AI. So let's see, from my previous discussion, number 7 on the top 10 hit parade was the Graphcore. Just a quick sample, a picture there of the scalability they have with this mix and match dynamism, which I think is pretty cool. NVIDIA Grace. What you see on the left is the way we build AI today, hardware, right? Got a bunch of memory, got an x86, and that x86 then attaches to 4 or 8 GPU. That's pretty much the limit of a 2-socket GPU server. An integrated architecture would be very different. You take memory, you plug the memory into a CPU that NVIDIA is designing, all integrated via DPUs, and then attached to GPUs, 1 GPU per CPU. It's a very different architecture. Why are they doing this? Jensen Huang was very clear. So he can run trillion parameter AI models. Cerebras, I've mentioned, has a very different approach. They've built a Swarm X fabric to interconnect multiple CS2s, that's their wafer scale engine. And the Memory X provides a weight server across the Swarm X fabric of up to 192 CS2 servers. So again, the scale here is mind-numbing. So let's finish up here with just a few questions I'd like to ponder and need your help in pondering because I don't know the answers. Does the opportunity for massive models justify the tremendous expense required for startups? Now, we know Intel and NVIDIA and Google, Microsoft, yeah, they're going there. But what about the startups? Is this really a good business model? Is this a good business opportunity for them to pursue? I don't know. It may be these massive models just remain a niche, just the tip of the iceberg, and all the ice is down under the water doing smaller models. However, I doubt it. I think massive models will fundamentally change the use of AI, and therefore it will become, I wouldn't say pervasive, but it will become quite widespread. Will data center and cloud AI systems pivot from the current model, which I just showed, to a new model, specifically to support large models? Don't know. I would imagine they will if money can be made. What about your AI vendor? Do they have a strategy to support large models? Some do, some don't. How will server vendors participate in large models? I mean, if the architecture has to change, can you buy it from somebody besides NVIDIA? Or can you rent it from somebody besides Google? I don't know where they go in this world. I do believe, however, that NVIDIA has a history of making sure they enable their OEM partners to come right along with them. So I suspect they'll solve this problem. And finally, and this is more for the philosophers in the crowd, perhaps legislators in the crowd, how will trillion parameter models be controlled? Will they be controlled? Will their use be safe? Can we avoid bias of training data providing leading to misinformation of stated facts that are not facts, of misrepresentation of not only facts, but of people? I mean, we're already to the point where we can generate, limited fashion, but we can generate human imagery and voice that is indistinguishable from the real deal. Look at Jensen Huang's short little Omniverse demonstration at GTC, and you can see that we're getting there. How do we control this? Should we control it? And what will the impact of society and the economy be? As always, it's going to be a fun ride. Thank you all very much for your time. I hope you have a great day. Take care. Stay healthy.